Well, hello everyone. This is Mark Pastor. I'm in the product management group at Quantum. And in this session of our virtual queue protect and archive day, we're going to talk about how to build an archive storage at exabyte scale. And the subtitle, I think, is really important here. I talk about hyperscaler practices for enterprises and service providers. And that's a little bit of an insight in terms of, how Quantum has developed some of the technologies and approaches that we'll be talking about today's presentation. We've got a very strong piece of our business is serving these very large exabyte scale customers, and we've learned how to get the most efficiency out of the storage technologies that we have. And so we'll be sharing a little bit of that with you on how to do that today. You may, through the day, if you've been participating in several of these sessions from Quantum, may have seen a bunch of these slides. I'll go through them pretty quickly on the front end. One of the reasons why exabyte scale archives are so important is because we're seeing this incredible growth of unstructured data from all these different sorts of applications related to intelligence and high performance computing, security applications, smart factories, smart cities, just all sorts of new things, not to mention the traditional, large data environments such as video and entertainment. So anyway, a lot of these sorts of use cases are now being practiced more and more because the tools have gotten more readily available within many enterprises, and many enterprises are setting up IT structures to effectively operate as services to their users. And we also have a lot of organizations that are forming services that they can offer publicly to other companies. And so, a lot of service providers amongst you as well. And so these technologies can really help with both of those. So this is really, while this may be somewhat of a vertical or industry organization listing, what I just mentioned is a lot of these sorts of use cases are actually happening within the same environments. And so all this data is coming together. Sometimes single ones of these applications are certainly large enough to create, tens of petabytes, hundreds of petabytes of data that needs to be retained. But if you start blending these and mixing them together, of course, it multiplies. One of the other things that we see is that there's an incredible pace. Not only is there a lot of data generated, but it's actually generated at a pretty high rate, and that keeps growing as well. So that could really cause, almost geometric growth of data retention because you're getting more use cases, but each use case is also, increasing in terms of, whether it be resolution or frame rates, of various applications or number of sensors. It's all continuing to contribute to these very large scale archives. And one of the things that certainly we've learned in the past several years being in the data protection space is that traditional data protection techniques really don't work for these large unstructured archives or for large unstructured cases of data. A lot of this data is not compressible, like typical structured data is, and so you can't, compress it or dedupe it. Snapshots is not necessarily an applicable way to go, and these cases are so very large that you can't really crawl file systems and scan them for changes through the day. And it's been our experience and many of our customers' experience that traditional methods just break down as the scale gets very large. And so we're looking for, other ways of protecting this unstructured data that's being gathered and collected and retained for very long periods of time. So I think, we've talked about it, and I think, key point is, with all of these use cases, what we are finding indeed is that the generation of this type of data also creates a tremendous amount of value. And so whereas you may, in the traditional protection world, create backup of your data that may live for a while. You may keep a retention of a monthly or a yearly backup. and then all the other backups in between will disappear. In these cases, you're creating an original instance of content or data that may or may not be reproducible, and you need to retain that, and it's got to be very durable because it's pretty much a precious commodity in many of these use cases. So what you're looking for, and we just had a session on object storage a couple hours ago, and really the requirements for large repositories of very valuable data are pretty consistent. You know, the challenge is, how do I store a lot of data that needs to be retained for a long time? You need scalability. If you're going to set up an infrastructure, you don't want to have to keep replicating it or you know, refreshing it every 3 years or 5 years, whatever it is. You'd like to be able to set up an infrastructure that can grow with you over time in a fairly non-disruptive way, or a very non-disruptive way. You need to protect this golden copy of data that I talked about, and so it's got to be very durable. You need to know how you're going to protect it so that you don't get, you know, bit loss and data loss. You also have many ways you want to protect against site disaster or things like ransomware and threats like that. So the data's got to be very durable from a whole bunch of different sorts of threats to that data. And since we're talking about at scale, the title of this presentation is Exabyte Scale, but even if you're talking about petabyte or tens of petabytes or hundreds of petabytes, you know, those very large scale use cases end up costing a lot. And so if you can have differences in cost of technology, you know, 20%, 50%, 10%, you know, those sorts of differences make huge differences to the bottom line of organizations that need to retain this data. So you're looking for low-cost technologies. And of course, you need a solution that's going to integrate well with your applications, whether they be file-oriented or object-oriented. And of course, you know, having proven solutions, you know, is very key, so that you can have the confidence that the systems will work for you. So what we described in previous discussion where we focused on object storage was that typically people think about these various choices for these large-scale archives, whether it be object storage or public cloud or tape technology. And I think these are all very viable technologies depending on what your goals are. We spent time talking about object storage, and the case for object storage is really where you want to have online access, you know, a little bit more performance, you know, and you're willing to sacrifice, you know, economics for having, you know, online source of orientation and full access to your data. And that would differ from tape technology, where tape gives you the absolute best economics for storing your content. And so that's what we'll focus on in this session. Of course, public cloud, you know, has gained a lot of attention for archive use cases, and I'll talk a little bit about how these technologies compare on this slide right here. So if we look at the solution options, if you look at public cloud, you know, it has an OpEx or, you know, on a regular payment, recurring payment structure to it. That's actually one of the things that makes it very appealing for a lot of users, is you don't have to have a large capital outlay, and you can get in for a monthly payment, start to use it, and you can go as long as you want. But once you want to stop your payments, you know, you have to figure out what are you going to do with the data that you put up there. There's a bunch of reasons why I would argue, and I'll, as we go through this slide, you know, you'll hear, you know, I don't know that public cloud is the best option for very large scale, long-term retention archives, because this OpEx, this regular payment will keep going, and it'll keep going, and it'll keep going. And so the longer your term of storage, the less economically attractive, you know, this type of an infrastructure works for you. There are also egress charges. So also if your data has some level of activity to it, so if you need to retrieve content back for various workflows over time, then of course that can also work against you because with most of the public cloud options out there today, you do have egress charges to retrieve your data back. So that even adds more to the cost. But public cloud infrastructure is very strong in the sense that it can offer you DR protection, so it's off-site. Many services can offer multi-site storage so that you can protect yourself against a specific data center failure. And you can even, select, different regions to store your data. And a lot of them have integrated protection solutions such as multi-copy or erasure code for your data. So they have been designed to offer durability and protection for your data. So they do that quite well. But as I mentioned before, at scale they get pretty expensive. So if your retention is fairly small, I think public cloud's a great solution. It can offer a lot of things to you, but don't forget the charges will never stop as long as your data is being retained in that bucket. We talked about object storage, as I mentioned. It has a lot of the same characteristics actually as public cloud in terms of the strengths. So it's got the DR protection with our active scale technology. It's based on erasure code rather than RAID, and so you get the durability of erasure code. We also have the ability to span our solution across multiple geographies, and so you can actually also have business continuity and site disaster protection with an on-premise object storage solution. And it is better than public cloud in the sense that you get lower cost at scale. So you make an investment, and eventually, that investment will amortize and pay for itself. And you can decide when you want to refresh. And there's a lot of things that I talked about in the object storage session, where these solutions can kind of live on. And ultimately, the economics are much better than public cloud. And then the other clear differentiator is that with an on-premise object storage, you have online access to your data. So it's effectively, online data without egress charge. And you get performant retrieval of your data as you need that. So object storage is really good from that perspective. However, it still has a price tag associated with it. It's low cost, but sometimes you might not have the need to retrieve your data very often, and you're looking for the best economics. And in many cases, people are driven for an on-premise solution because they do want to have their data readily available when I want it. I do want it on-premise. I don't want to have to pay for high bandwidth access. I don't want to have to pay egress charges, and I certainly don't want to have to pay every month for 10 years or 15 years or 20 years as I retain my data. So, and I do want to protect myself against ransomware and those sorts of things. So that's where tape comes in. It can absolutely address all of those things. It gives you the lowest cost storage at scale. You don't have any egress charges, so I say I'm going to egress there. You can configure the solutions, and we'll talk about this for DR protection and durability. And again, like I mentioned, you have on-premise access. So we'll discuss, so in this session, we'll just describe a little bit about how a tape solution would look to address this for use case. I did provide a TCO comparison against object storage in the previous session, and I compared object storage to Glacier and to S3 storage because it really provides the type of access, or even more performant than traditional S3. And so object storage was substantially less, than S3, and it was also, significantly less than Glacier storage as well. But here we're going to compare tape to Deep Glacier, which is the lowest cost public storage type of service that I've seen out there. There's a few offerings of that. I'm using AWS Deep Glacier nomenclature, to identify that type of service. So it's a deep archive service where I don't expect a lot of access to my data. And if I do want to access my data, I'm going to have to wait, for some period of time before I get it, unless I pay for expediting fees and things like that. So you can see here that protected tape in an on-premise environment can even beat Deep Glacier-like costs. And this is on a 5-year TCO comparison. This is just an example arbitrarily of 34 petabytes, which we define because that happens to meet the capacity of a certain set of tape libraries. And so this is just an example. If you've got a 34 petabyte archive or something on that order, you would see these kinds of comparisons, for cost. So let's talk about what this solution might look like. So recently, in the past month or so, we've introduced a new version of StorNext, which is Quantum's high-performance file system. And so by leveraging StorNext as a front end to our tape technology, we can actually present the data and the content in a file or an object orientation. And by adding a new feature that we call DLP, or dynamic library pooling, which I'll talk about in a moment, we can actually orchestrate a number of libraries. And you see here we've described RAIL, which is a redundant array of independent libraries. And in the picture, we show our Scalar i6 libraries. Those libraries are rack-based libraries. And what we found, and this comes back to the experiences that I was describing at the opening slide, when we have looked at the best way to architect these exabyte scale archives, what we have found that if you can tie together a bunch of independent libraries, you can add incredible availability and durability of your content. And you can also take advantage of extremely high density of these rack-based libraries. So, and you basically can keep scaling forever. You can just keep adding one library after another. You know, you can start out with 4 libraries, and if you need to add 2 more a year later, you can do that. And so it's incredibly scalable. And by also doing it this way, you don't have to worry about contiguous space availability, kind of a side benefit. You know, traditional enterprise class libraries, you know, have been built on frames, and they'll have to connect to each other. With a redundant array of independent libraries that are rack-based like this, each library has its own robot. That adds even more redundancy to the system. So you actually get 100% redundancy in these systems, which raises your availability and durability of content. So this is really an exciting concept to be able to stack libraries together like this. But of course, you need software that knows how to do that, and that's where StorNext with DLP comes in. So just to give you a little bit of a graphic on what that looks like. So with dynamic library pooling, we basically have StorNext software which presents a file system or an object presentation of your content. It comes into the file system. We have an ingest cache, of course, that's disk or flash based. So you don't have to worry about the performance of ingest. You basically size your system accordingly. And then StorNext has always had integrated data management capabilities. So you have the ability to tier that data from this ingest tier, which can also be used as a high performance tier for real workflows. So you can do HPC, you can do media editing, and all kinds of work like that. So you can build the cache into primary storage for use cases that need it. Or you can just have it be acting as a cache and keep it small, knowing that all your data then will be offloaded to the secondary tier, which here is based on this redundant array of independent libraries. And the real interesting trick that we've done with our latest revision of StorNext with dynamic library pooling is we organize it in a way that we can actually capitalize on the pool of libraries in a fairly intelligent way, so that we manage, the utilization of the library's resources. So you can actually basically take your first chunk of files or objects and you put them in the first pool of libraries, and then your second chunk of objects will go in the second pool. And this is really important to avoid hotspots. If you have really active workflows at various times of the day, this way not everybody's not hammering on the same set of libraries to get the data written to tape. In this case, you create a pool of libraries that we rotate them around in, which effectively does wear leveling, it does performance enhancement and all that. So there's a lot of benefits to being able to write data and read data from libraries in this kind of an organized fashion. And what we find here is you get the lowest cost storage with extremely high density, probably the highest density you can find, at the lowest cost. So benefits of DLP with RAIL is, as I mentioned before, you get improved durability and availability because of the way we round robin the data across the different pools of libraries. In the event that you actually have a failed library, your data will be retrieved, because part of the intelligence is to make sure that the primary copy of content is not solely on one library. So we'll make sure that your content is spread across various libraries. And of course, it takes advantage of wear leveling all of the components within the system, including the robots. I talked about the density. Scalerized 6 is among the highest density libraries out there in the industry. And so when you consolidate them for your mass storage, you basically have, a very high density storage pool, within the system. You also can have performance gains, by if I have a lot of users retrieving content at the same time, we'll be able to spread that load across the various libraries where the data resides. And so you're not looking for any kind, it becomes a lot less sequential from a file-to-file or user-to-user basis. And so you can capitalize on that, and you can see some pretty good performance improvements by doing it that way. And of course, as I mentioned, you can keep adding libraries as needed where you need to scale up. And that's a very non-disruptive thing. You just set up a new library, you add a new pool into the logic, into the policies, and that all of a sudden becomes integrated into the total storage pool. So pretty quick and short presentation, but we certainly wanted to whet your appetite, for how companies that are involved at hyperscale or exabyte scale are doing this, and what are the tricks of the trade that we've learned to help them maximize economics, for archive-oriented use cases by leveraging tape technology, the most modern type of tape technology, but you need software to help organize it properly, and you can leverage our StorNext with DLP in a way that provides, the level of either cache or primary storage in front of tape libraries to do exactly that. So Quantum StorNext with RAIL provides the lowest cost, highly scalable archive storage available in the market today. So hopefully that was informative. If you have any questions, we certainly want to make sure that you do contact your local Quantum representatives. I'll see if any questions showed up here in the Q&A, but certainly as you follow up, you can feel free to reach out to me or your local Quantum representative. And we do thank you for your time. I appreciate you hanging out there late in the day for a very long day if you've been part of many of the sessions. And hopefully that'll be useful for you. Thank you very much.